Hello, in this video we will be discussing phasors. Um, we will develop an understanding of what a phasor is and how to transform from the time domain to the frequency domain and vice versa from the frequency domain to the time domain. But let's first figure out what is the time domain, what is frequency domain, what are phasors. The solution to circuits with sinusoidal sources is phasors. And what we will be doing in this chapter sorry about this awful writing, is we will learn how to take a sinusoidal source and convert it to a phasor, which would look something like this. And we will also convert a resistor to its impedance and a capacitor to its impedance value and an inductor to its impedance value. All of these have unit of ohm. That's a terrible. That's a little better. But first, let's take a look at phasors and what they are. Our sinusoidal input is in time domain, and when it's converted to a phasor, it is in frequency domain. Oops. And it can be written in polar form or rectangular form. Okay, and the form that your final answer is usually expressed in is this one. However, let's do a little review of complex math, and you'll discover that one form is easier for adding and subtracting, and the other form is easier for multiplying and dividing. Okay, complex numbers allow us to find the square root of negative numbers. Okay, we saw this in chapter 8. But let's talk about complex numbers a little bit here. And I'm going to add a page here. Okay. So complex numbers are usually in math. That's terrible. Let's see. You've heard of the Cartesian plane. with x and y, but instead of x, this is the complex plane, and it will be our real numbers, and instead of y, this will be the imaginary part. So in rectangular form, this is the real part, and this is our imaginary part. So if we had 3 plus, and it could be written as 4j or j4, and again, in electrical engineering, we use a j. In math, you probably learned it as an I. But 3 plus 4j would be 1, 2, 3, 1, 2, 3, 4, and that would get us right there. So this is a vector, and v, if we use the Pythagorean theorem, Vm is the magnitude, and it is a squared plus b squared square root, and phi would be the inverse tangent of the imaginary over the real. Okay, so we know that j is equal to the square root of minus 1. And j squared is minus 1. J cubed is j squared times j, which is minus 1 times the square root of minus 1. J to the fourth is j squared times j squared. J to the fifth is j to the fourth times j. And we'll just say j. And actually, I'm going to move this up here. Let's do this. Make some room here for myself. All right. So j to the sixth is j to the fourth times j to the second, which would be 1 times minus 1. J to the seventh is j to the fourth times j to the third, which is and j to the eighth is j to the fourth times j to the fourth. So you'll notice that these are looking very familiar, that our pattern is repeating. So we could draw something like this. which is minus j, and j to the fourth, which is 1, and then j to the fifth, j to the sixth, j to the seventh, j to the eighth, and then we would go up to the next one, j9, j to the 10th, j to the 11th, j to the 12th, etc. And what you'll find is these 4 basic patterns repeating. So knowing that will come in handy at some point. Okay, I'm going to add another page here, I think. Okay, so as I mentioned, we use the Pythagorean theorem to convert from polar form to complex plane. Polar form would be like this, with a magnitude and an angle. And we would convert polar form to rectangular using the Pythagorean theorem. Okay, so let's take a look at, so these are phasors. These are all considered phasors. And this is polar form to rectangular. So we have 5, 20 degrees with an angle 20 degrees. So to convert that to rectangular, when you look at this up here, we are given phi, the angle phi, it's 20 degrees, and to find the real portion, that is the cosine of phi, and to find the imaginary portion, that would be the sine of phi. So A is our real portion. So A is equal to the magnitude 5 times cosine of 20 degrees. And B is equal to 5, the magnitude, times, oops, that should be sine of 20 degrees. So A is, make sure your calculator is in degree mode. 5 cosine 20 is 4.7. 5 sine 20 is 1.7. So in rectangular form, this would be written as 4.7 plus j 1.7. Now, if we wanted to go from rectangular to angular, let's take an example of that. So we have 2 plus j3. How do we go back to polar form? Pythagorean theorem. So we would say 2 squared plus 3 squared is equal to 3.61. And our angle phi is equal to the inverse tangent of the imaginary divided by the real, over the real. So opposite over adjacent. So inverse tangent 3 divided by 2, and that would give us 56.31 degrees. And that's how you go back in that direction. Okay, let's see here. Let's bring this picture up here, and you can see some different examples here where if we go from 4 plus j3, we can map that as the magnitude is 4 squared plus 3 squared square root, which is equal to 5, and phi is equal to the imaginary, inverse tangent of the imaginary over the real, which is equal to 36.87 degrees. And there you have that drawn. So this is how you would draw, or you would say 1, 2, 3, 4, 1, 2, 3, right there. All right, let's do some math. Adding and subtracting. It is very easy to add and subtract when the phasor is in rectangular form. So 4 minus j3 plus minus 4 minus j3 is real plus real, plus or minus imaginary plus imaginary. So in this case, it would be 4 plus minus 4 plus minus 3 plus minus 3. So that would be, oh, this was not a good one, 0 plus 0j. Let's take another one. 5 plus 3j plus 4 plus 2j. That would be 5 plus 4 plus 3 plus 2. So that would be 9 plus j5. So you can write the j after the 5 or before the 5. Let's subtract something here. So 6 minus 5j minus 4 minus 3j. I guess I'm doing a lot of negatives here. That would be 6 plus, 6 minus 4. 6 minus 4 plus minus 5 plus 3, which is 2 plus, that would be a minus, 2 minus 2j. Okay, multiplying and dividing. It's a lot harder to take rectangular forms. So let's say 5 plus 3j divided by 4 plus 2j. In this form, you would multiply by the conjugate of your denominator. So 4 minus 2j, and multiply it to the top and bottom, and figure it out that way. Very doable, but it can get complicated. So it's easier to multiply and divide when you have it in polar form. Times so in polar form, this is equivalent to 5e to the j 30 degrees times 4e j 20 degrees. And we would multiply these and add the angles there. So that would equal 20 EJ 50. So we do the same thing, but without pulling it out. And we say that this is equal to 4 times 5, which is 20, and 30 plus 20 degrees, which would give us 50 degrees. And dividing 5, 30 degrees to 20 degrees would be the same deal as writing 5EJ 30 degrees over 2e to the j 20 degrees. So you would divide 5 divided by 2 and subtract 20 from 30. Or you could do it directly without having to put it in this form, and you would get 2.5 and 10 degrees. Okay, let's see if I have anything else here. All right. So as I said up front, a sinusoidal source could look something like this. But let's convert from time domain to phasor, which is also called frequency domain. Okay. So let's say that we are given Vm cosine omega t. All right, and let's convert that to phasor. So Vm cosine omega t is Vm cosine omega t plus a phase shift of 0 degrees. So converting that to phasor, we would say Vm 0 degrees. But you don't have to write the 0 degrees. You could just say Vm. When you convert something to phasor, this was called V equals. When you convert it to phasor, it becomes a large V and in bold. So V equals. All right, let's do another one with the current. And our text just shows a current source looking like this, but you will see this out in the real world with a squiggle through it. All right, let's convert this one to phasor. So it would be a capital bold I, and this one would be a little I, is equal to plus 30 degrees, and that would be amps, and this is volts. All right, let's say that we are given a voltage source with so you would first convert this to cosine, and as I had said before, that would be shifting it 90 degrees, and we'll convert that to phasor or frequency domain. So it's a capital bolded V, and it's equal to Vm minus 90 degrees volts. Okay, let's try a couple more. V of t is equal to, and actually when you have the symbol there, it doesn't usually have the V of t, but let's continue. Vm sine omega t plus 40, and let's convert that to phasor. So V, well, first of all, we need to convert to cosine. So this would be cosine omega t plus 40 degrees minus 90 degrees, which is Vm cosine omega t minus 50 degrees. So V is equal to, our phasor is equal to Vm minus 50 degrees volts. All right. Should put another current source in here. 7 cosine 377 plus 15 degrees. How do I convert that to phasor? This doesn't change. So we will remember that when we're working on the problems. But when we convert this to phasor, it would be 7 15 degrees volts. Okay, when we're working on problems, and I will repeat myself a few times here, but when we're working on problems, we will go from time domain we will solve the circuit in frequency domain. and then we'll bring our solution back into time domain. Okay. What happened to my example problems here? All right, let's take a look at this one. Find the phasor transform of each trig function. All right, first one. A. Voltage is equal to 170 cosine 377t minus 40 degrees volts. All right, so the phasor form of this is 170 and minus 40. All right, the next one. Current is equal to 10 sine 1000 t plus 20 degrees amps. So we are interested in this and this. However, we need to convert to cosine. So this would be 10 cosine 1000 t plus 20 degrees minus 90 degrees. So our phasor is equal to 10 and minus 70 degrees. All right, the third one, C. Current is equal to 5 cosine omega t plus 36.87 degrees plus 10 cosine omega t minus 53.13 degrees. And that's amps. Okay, you'll notice that the frequency is the same in both. Adding and subtracting, we said, was easiest in rectangular form. So to convert this from a frequency domain to a time domain, we can easily convert this to polar form. So let's go to polar form first. So this one would be 5 angle 36.87 degrees plus 10 angle minus 50. You know what? I'm going to change the color of this one. Um, 10 angle of minus 53.13 degrees. Okay, so let's add those two together. To convert from polar to rectangular, we take the magnitude, so this is polar, and I want rectangular so I can add easily. If I was doing multiplication and division, I could easily do this in polar form, but addition and subtraction is easier in rectangular form. So our real component is 5 times cosine 36.87 degrees, which is 5 cosine 36.87, and our imaginary is 5 sine 36.87. So 5 sine 36.87. That would give us 3. So in polar or rectangular form, this is written as 4 plus 3j. And now let's work on the second part, converting from polar to rectangular. So on this one, the real form is 10 cosine minus 53.13 degrees. So 10 cosine minus 53.13, and that's 6. And the imaginary part is 10 sine minus 53.13 degrees. So 10 sine minus 53.13 is 8, minus 8. So in rectangular form, this is written as 6 minus j8, and we'll add these two together. So 4 plus 6 plus 3 minus 8, and that would give us 10 minus 5j, and that's amps. All right, so let's put it back in polar form. And to go back to polar form, we use Pythagorean's theorem, so it'd be 10 squared plus minus 5 squared square root 10 that would give us 8.66, and phi is equal to the inverse tangent of the imaginary over the real. So that is minus 5 over 10. And that would give us minus 26.57 degrees. So to write this in polar form, it would be 8.66 minus 26.57 amps. All right, we have one more to go, so let's add another page here. And it is D. Voltage is equal to 300 cosine. So this was 11.8. All right, where did I go wrong here? So this is C 5, 36.87 plus 10, 53.13, 4 plus 3j, 6 minus 10.5, 10 minus 5, j. So this, everything is right, but the answer here is 11.18. So this should be 11.18. So this is correct. This is correct, but this is not. All right. 300 cosine 20,000 pi t plus 45 degrees minus 100 sine 20,000 pi t plus 30 degrees, and this is millivolts. All right. So, first thing we'll do is convert this one into cosine. So, we could say minus 100 sine 20 pi t plus 30 degrees. I mean, there's a number of ways you can do this. And let's convert that to a positive sign. So that would be 100 sine 20, 1, 2, 3 pi t plus 30 plus 180 degrees. Now let's convert that positive sign to a cosine. So that would be 100 cosine 20, 1, 2, 3 pi t plus 30 degrees plus 180 degrees minus 90 degrees. So our V, this is 100. I'll just finish what I'm doing here. 20,000 pi t, and 30 plus 180 minus 90 is plus 120 degrees. Okay, so the polar form of this one is 345 degrees, and this one is 120 degrees. So we have V equals, and actually I'm going to put that in polar form. So V equals 345 degrees plus 120 degrees. Okay, so it's easier to add in, and this is millivolt. When it's rectangular form, so we will take the first one, and the real of the first one is equal to 300 cosine 45, and the imaginary is 300 sine 45. And the real of the second one is 100 cosine 120 degrees, and the imaginary part is 100 sine 120 degrees. All right, so 300 cosine 45 is 212.13, and 300 sine 45 is 212.13, and 100 cosine 120 degrees is minus 50, and 100 sine 120 is 86.6. All right, so we take our real values and add them together. So 212.13 plus minus 50 plus, now we take our imaginary numbers and add them together. 212.13 plus 86.6, and it has a J. So 212.13 minus 50 is 162.13 plus J. 212.13 plus 86.6, and that's 298.73, and that is millivolt. And this is also in phasor representation. Now we will convert this from rectangular form to polar form. All right, so to do that, the amplitude is equal to a squared plus b squared, so 162.13 squared plus 298.73 squared, and the square root. So 162.13 plus 298.73, and the square root of all of that is 339.89, and our phi is the inverse tangent of the imaginary over the real of 298.73 over 162.13. So let's plug that in. 298.73 divided by 162.13. And we get an angle of 61.51 degrees. So our voltage is represented as 339.89, 61.51 degrees, and that should be in millivolt. All right, let's run up here and check our answer. Yes, all right. Love it when I get it right once in a while. Okay. All right. Find the time domain expression. All right, so A, phasor is equal to 18.6 with an angle of minus 54 degrees volts. And we convert that to time domain. This one's very simple. It would be 18. No, I'm actually going to. So V of t is equal to 18.6 cosine omega t, because we don't know it, minus 54 degrees. And that is volts. All right, B. So this current is equal to the polar form 20, 45 degrees minus 50 minus 30 degrees, that's milliamp. All right, this first one, the real part, let's convert this to rectangular form. So this one was in polar form, and this one is also polar. So we'll convert each of them to rectangular. So the first one, the real part, is 20 cosine 45 degrees, and the imaginary part is 20 sine 45 degrees. So 20 cosine 45 is 14.14, and 20 sine 45, 14.14. All right. And this part we'll say real is minus 50. And you could say positive 50 and subtract everything at the end of the day. Cosine minus 30 degrees. And the imaginary part is minus 50 sine minus 30 degrees. So minus 50 cosine minus 30 is minus 43.3, and minus 50 sine minus 30 is 25. All right, so let's add everybody together. So this one would be written as minus 43.3 plus J25. And this one would be written as 14.14 plus let's add those together. Um, 14 minus 43.3, we get minus 29.16. And this is milliamp. And let's convert this, and this is rectangular. And let's convert it back to polar form. So polar would be the magnitude, oh no, we're talking current here, is equal to minus 29.16 squared, 39.14 squared, square root, and that will give us .81, and then the angle is the inverse tangent of the imaginary over the real part. All right, so inverse tangent 39.14 divided by minus 29.16, and that would give us minus 53.31 degrees. So our answer would be 48.81 minus 53.31 degrees. Now if you look up here at the answer, it says 126.68 degrees. So if we added 180 degrees, that would give us 126.69 really, but which is the same thing. So I will accept that. All right, so C. V is equal to 20 plus J80 minus 30 with an angle of 15 degrees volts. Okay, so this part is written in rectangular form, and This part is written in polar form. So adding and subtracting is easier to do when you have both in rectangular form. Multiplying and dividing is easier to do when you have both in polar form. So let's convert from polar form to rectangular form on this guy. And so the real part, and you don't have to take the minus, but I'm going to, minus 30 cosine 15 degrees. Minus 30 cosine 15 is minus 28.98. The imaginary part is minus 30 sine 15 degrees. Minus 30 sine 15. That would give us minus 7.76. So if we write this out, B is equal to 20 plus J80 plus minus 28.98 minus J 7.76. So real to real, imaginary to imaginary. So 20 minus 28.98 gives us B equal to minus 8.98, and 80 minus 7.76 would give us 72.24. And convert that to polar form. So the magnitude of the voltage is equal to the square root of minus 8.98 squared plus 72.24 squared. All right, minus 8.98 squared plus 72.24 squared, and the square root of that would give us 71.68, and phi is equal to the inverse tangent of the imaginary part over the real part, which is equal to 72.24 over minus 8.98, which would give us, all right, inverse tangent 72.24 divided by minus 8.98. That would be minus 82.91 degrees, and let's add 180. I don't know if they did that, which is 97.09 degrees. Okay, so in time domain, and let's see, was this volts from the get-go? Yes, okay. All right, so our big V polar form is equal to 71.68 and 97.09 degrees, and that's volts, and they want it in, so this is frequency domain, and they want it in time domain, which would be 71.68 cosine omega t plus 97.09 degrees volts, and this is time domain. All right, let's see how we did here. 72.79, 97.08. Okay. My numbers are off a little bit. Let's see, I did do this. This is C 28.98, 7.76, 8.98, 72.2, 72.79. For whatever reason, all right, so I got 72.79 first time I did that. And okay, well, as long as you write everything out and I know what you're doing, I can see what you're doing, I'm okay with it. So I'm going to reiterate, when we are solving circuit problems, we will be given a voltage source or a current source as 72.6 cosine 377, and we will have to convert it. In order to solve this circuit, we will have to convert everything from the time domain to the frequency domain, specifically as we will represent everything as phasors, back to time domain. Okay. So the next videos that I do will go into that and how we will be using all the same techniques that we used, that we've already learned, such as Kirchhoff's, laws, Ohm's law, Thevenin and Norton, nodal analysis, I can't spell, mesh analysis, source transformation. Everything we learned before for analyzing circuits, we will do again, and we will learn how to do it in the frequency domain or using phasors. Okay, that's the end of this video.